Welcome back to another video. In this video, what we're going to do is we're going to use a NBeats time series model and also an XGBoost model to put in another visualization in here. So it gives us a prediction about the future sessions or page views. So we have the page views graph in here, where we have the actual page views and also the sessions. And then we're just going to put in another visualization here inside the sidebar or in the main page that shows us the predictions, what our page view is going to be, maybe 2 to 3 weeks into the future. And we'll use the Modeltime library and the GlueOnTS library and also the TimeTK library to do that. And we'll also use some libraries from the Tidymodels package. So just going to load our libraries first. The Tidyverse, Modeltime, and then Modeltime GlueOnTS. That's the development version from GitHub, not from CRAN. And then we'll load TimeTK as well. And then what we'll also do, we'll load the Tidymodels package. So we have these 3 libraries. And for the Modeltime GlueOnTS package, you also need Reticulate and Python installed in order for it to work. So what I already did is I pulled the most recent data. So we have the web_data that we've worked with so far for all these videos where we built the Google Analytics dashboard. And I just did another pull I call the df_today, and we're going to use all the data from 2019 until now to build the model. So what we'll do is we'll read in the most recent pull, then we'll read in the web data, and then we'll binding the rows and summarizing the page views, and then we'll make a daily time series forecast. So we'll use the readr package and also the here package. So we go from the project directory, which is a GA dashboard. Then I have another folder in here, GA dashboard/data/df_today.csv. This one looks like this. So I pulled it where we left off here with the web_data. Or I think I also pulled some dates earlier as well. So let's do the same thing for the other data set. Web_data, and well, I read it in here as well, so we can just copy it. Then we'll read that in, and this one looks similar. So what we can do is we can just summarize the page views. So we'll group by the date, and then we'll summarize the page views column. And this is the sessions column. Here we have the page views column. So we'll say page_views is equal to sum page views. And then we'll ungroup it. So for the web data, we'll do the same. And then what we'll do, we'll have, well, the web data is the older data, so we'll say web data, then we'll pipe it, then we'll use the bind rows function, bind df today, so the columns are the same because it's the same data source from the Google Analytics API. And then what we'll do, we'll just say distinct. The column that we do that by is the date column. And then in order to keep the page views, we'll say dot keep all is equal to true. By default, it's false. And if we run that, we have now data from January 2019. And I started my blog late 2018. And let's call this df. And then we'll just look at the range of the date. So it's df date. So we have it until the 8th of December 2022. So we have around 1,400 data points. And what we'll do now, we'll use the GlueOnTS, Modeltime GlueOnTS package to use an NBeats model to forecast the page views. Let's do 21 days in advance. So what we can do now is we can arrange, it's probably already arranged by date. Just to make sure, we'll arrange it by date. And then we'll use the time tk function. And this one has our time tk package and the future frame function. So here we have the data argument, which is like similar to all the tidyverse packages and functions. It's the first argument of the function, then the second one is the date variable, which is called date in our data frame, and then the length out argument, which is going to be for us 21 days in advance. And then we'll say bind data is equal to true. So it gives us a data frame. So it gives us an empty data frame from December 9th or December 8th plus 21 days. And the page views values are all going to be NA because it's going to be in the future, and it just fills out the date column accordingly. So we can say dot date var is equal to date, and then dot length out is equal to 21 days. So if we would just do that, we'll just get a, one second. Yeah, we'll just get a data set that just extends the date. Here it goes from the 9th plus 21 days. But we'll say dot bind data is equal to true. And then what it gives us is the entire data frame. And if we do TLDF, then we have NA for the page views because they are in the future. So what we can do next is we can define a recipe, and we can also first look at the Modeltime GlueOnTS NBeats function first to see its arguments. So if we run that, we'll get the documentation in here. So what we need to have is an ID variable. So what's cool about the NBeats model is that it could give us different time series for different groupings in our data set. So in our data sets, there are no groupings, but what we could do is, for example, we could create individual time series for example, for the source where the data is coming from, if it was direct traffic from Google, and it would give us a time series forecast for each of these sources. Or we could make a time series forecast for all of the individual blog posts and predict the page views of each individual blog post into the future. But so this would then, the ID would then equal to the grouping variable in our data set. So we don't have an ID yet. And because we don't have any group, we're just gonna say dplyr mutate, and then we'll give it an ID. And if we look at the ID here, yeah, it says a quoted column name that tracks the gluon_ts field name item ID. I think this one has to be a factor, so I'm just gonna say as.factor1, just so we have an ID in that data frame. So now what we can do, we can specify a recipe. So we'll say just recipe is equal to, this is the recipes package, recipe. And then what we want to do, we want to regress page views on date plus the ID. And then the data is equal to, we haven't created the data set yet, but let's say training. And then what we want to do is we want to define a training and a testing data set. And I would say we only test on 7 days and then train on the rest of the data. So what we can do, we can just define it ourselves. So what's important for time series is that we can, or we could, depends on the model, but we don't want to shuffle the data. So what we're going to do is we're going to say training, and let's first make a variable for the prediction length. So we'll say prediction underscore length is equal to 28 days. So what we'll do instead of 21, we'll put in the prediction length in here. And then for the training data, we can leave this 21. For the training data, what we can do here is we can say training data is equal to the data frame. The rows that we want to select is 1 until, and we want to have 7 days of testing. So what we want to do in here is I want to say nrow df, and then we'll say minus. So we have 21 days where the page views are missing because we inserted NA values with the future frame function. So what we want to do in here is we want to say minus prediction length, and then we'll select every variable. And then for testing, we'll just do the opposite. So if we run training, and we'll do tail training, we'll see that we have until the 1st of December for training. and then testing should be the 2nd until the 8th. So what I can actually do is I'll just copy this, and then for this one I'll say df $ date is greater or equal to looper date, year, month, date, and then we're gonna put in here, or actually we put in here the max value of training $date, and then we'll select every column as well. So if we look at testing, we've selected, yeah, it should be greater than, not equal, greater than or equal. We select the 2nd until the 8th for testing, and then we still have the NA values in here, which we can deal with later. I think it's fine for now. So then let's run the recipe, because we've defined the training data, and then we can look at the Modeltime 31TS function, NBeats function from the package. So what we'll do next is we'll say NBeats _model. Then we'll use the NBeats function. So the default is regression, so we can just leave it. ID is equal to the ID. Here we called it ID in our data frame. Then the prediction length is actually equal to prediction length. So it's going to be 28 days. So what we want to do is we want to predict the first 7 days where the data is available, plus the 21 days into the future later. So that's going to be 28 days. And then we have the look back length, and in the paper it says the look back length should be 2 to 7 times the time horizon or the prediction horizon. So what we'll do is we'll say prediction length times, let's do 2, 4, 6, 8. I'll make it a little bit bigger, so I go over 7. I'll do 10 and 12 times the prediction length. Then we'll do bagging size is equal to 5. The loss function is equal to the mean absolute squared error. Then we'll do scale is equal to true. I think that's really important if you have a grouped time series where maybe some values inside the groups are of a different scale. So maybe some blog posts only gets 10 page views a day, another one 200-300 page views. So the scales are different. So I think, I'm not sure if this is important for our time series, but I'll just leave it as scale is equal to true. Then I think the epochs I'll leave as well, I think, or I'll just put it in. I think the default is 10. And in my experience, it's not less is more. So if you do 100 or 200, the model overfits hard. So 5 to 10 epochs are generally enough when I've done these time series, deep learning time series. And then we'll also have the num batches per epoch, where I just put 16 in. And then what we'll have to do, we'll have to set the engine. So I'll say parsnap set the engine. And I'm not sure if it's mentioned what the engine should be in here. Let's look at the examples. So we'll say Gluon-TS NBeats, and yeah, we have debugging argument in there. So what we'll say is, we'll say model Gluon-TS ensemble. And this doesn't work, so let's just see what we get here. Okay, so we want this one, the ensemble one. Cool. So what we'll need to do next is we'll have to combine the recipe and the model. So we can use the workflows package for that. So what we can do is we can say workflow underscore fit, and this one is equal to, we'll set the workflow, is it workflows? Yeah. It's the add, yeah, it's the add model, which is the NBeats model. Then we'll do add the recipe, which is the recipe. And then what we'll do is we'll say parsnip, and then we'll do fit. And then what we'll do is we're going to use the training data to fit the model. Oh, and what I forgot is, so there's so the frequency. So either if it's a monthly, daily, or hourly time series. So in our case, it's daily. So we'll say frequency is equal to D. And then I'll run this. I forgot the comma. And now it's going to train the model. So this is going to take a while, so I'll see you when this is done. So the model is done training. It took around 20 minutes for the entire thing to be done. So now we want to predict. And what we are going to do is we're going to put the workflow into a Modeltime table. So how we're going to do this is we'll say Modeltime underscore table, and in here we have the workflow fit, and we can save this as models. So what we can do next is we can do the forecast. The forecast will use Modeltime, and then we'll use Modeltime underscore forecast. And in here we have the object, which we can get from the Modeltime table, which is called models. Then we have new data, which is going to be the testing data, the actual data, and yeah, that should be everything. So the object was the models. I called it models. So for now, it's only the NBeats model. Later on, the gradient boosted decision tree will be in here as well. Then we'll have new data. And the new data, we can say testing. And then actual data, we can say training. Or we can say DF. Because this includes training and testing data. So what we're going to do is we're just going to remove all the NA values. So we'll say filter is.NA page views. And then if we do tail, it should go until the 8th. And then for testing, yeah, let's leave it at that. And then we'll say keep data as true. And then let's run this. Let's save this as NBeats underscore predictions. And then what we'll do next is we'll use another Modeltime function. It's called plot Modeltime forecast. And in here, we're going to plot the forecast. So here we have the entire time series from January 2019, and here this is the prediction. So in this plot we don't see much yet, so what we're going to do is we're going to slice the actual data set. So we'll say dplyr, well, it's actually filtered in a different way. We'll use the square brackets, and then we'll say df page views should not be NA. And then what we'll also do is we'll say date is greater than or equal to so the testing max date, I think, is the 8th. So if we'll say max testing date, oh, it's going to be the 29th. Okay, so for now we're just gonna say looper date, then we'll say year month date function 2022. We'll just have some actual data in here from the 11th, from November. Then we'll select all the columns. Let's do predictions for this, and we'll get an error. Okay, because I have to do df data, data $date. and then afterwards we can plot it. So it gives us a warning message about the confidence intervals, but now we can actually see the prediction better. So the actual data starts from the 1st of November, and then here it makes the first predictions for the 2nd of December, and then this is the first week where we can compare how the prediction does. So it did decent here. It gave us the low. For the high, it didn't predict as well. It could have gone a little bit higher, and then it's going down a little bit towards Christmas, which actually makes sense. So now we're gonna compare the NBeats model to an XGBoost model, and then we'll see what model does better. But both models are going to be in the Shiny application later. So for the XGBoost model, we have to do some data preparation first. Just going to make this a little bit more clear. It's the NBeats model, and then this is the XGBoost model. So in here we have the data frame, and then what we're going to do, we're using the time tk package, and then here we'll say tk underscore augment lags first. So first argument is the data. The value is, so dot value is equal to page views, because page views we want to lag into the future. And I'm not sure if it's quoted. Let's just look at the documentation first. So if we have tk augment lags, okay, so we'll just say page views, and then we have the dot lags value, and this one is equal to the prediction length, 28 days in advance. Then what we can do is we can also put some moving averages in here. And in order to do this, I am going to create a vector in here of the rolling averages we want to do. So what we can do is we can say prediction length, which is 28 days. And then we can have, let's do maybe 3 rolling averages. So we'll have prediction length, and then what we'll do is we'll say times, so just prediction length times 2, and prediction length times 3. So we have the 28, 56, and 84 rolling average. And in order to create these rolling averages, so right now the data set looks like this. Because we lag the page views into the future, that means that we can't use the beginning of the data set, because we have NA values here, so we have to remove them. So yeah, for our data set it's no problem, but you have to be careful with yours. If you only have a limited amount of data, it might make not too much sense to sacrifice some data in order to lag it into the future. But I think we have enough data, and the data points from January 2019 or for the entire year, they're somewhat useful, but there's a diminishing return, and I think the time series might look quite a bit different than it was 3, 4 years ago, where I started out with the blog. So I think it's fine to just remove these rows in order to lag the page views column into the future and trying to get the trend into the future as well. So, okay, so we have time tk, and then we'll use tk, and then I think it's called augment. I'm going to use augment free in a bit, but in here we have augment slidify. So in here we also have the value, and the value is going to be page views underscore lag 28. That's the one where we have a rolling average of. So yeah, what we'll do is we'll use the bang bang from the, so if we just want to do, so what we could do is we could just put the column name in here like this, but if we change the prediction length, then the 28 changes. So if we want to only predict maybe 2 weeks in advance, and this is going to be 21. So what I'm going to do is I'm going to use the rlang bang bang syntax, and in here I'm going to say paste 0, and then in here I'll have page views underscore lag, and then I'll have prediction length in here. And then let's look at the documentation for tk augment slidify. So the data, it's automatically in there because we piped it in there. Then we have the dot value argument. Next, we need the period. So the period I already specified here. It's going to be the rolling averages. So we'll say dot period is going to be rolling averages. And then we have the function. So the function, it's going to be the mean. So we have the weekly sign for the anonymous function. Then we have the dot placeholder. Because we have lags in there, we'll say na.rm is equal to true. Then what we'll say is, we'll say dot partial is equal to true. And then we'll say dot align. You can choose between center, left, and right. I'm just going to choose center. And now, if we do tail, we have 3 additional columns in there now. So we'll have the page views lag 28 that we already had in there, and then this is the 28 rolling average, the 56 rolling average, and then the 84 rolling average that we are going to use in our training data. So what's next is we'll add some other columns. So we'll do some more feature engineering, and we'll say augment tk augment free. And in here we have the data is the first argument, then the date var is, so dot date underscore var is date, and then what was the other one, dot period, I think. Dot periods in the free series, so we'll say dot periods, and for this one we're also going to use the rolling averages, and then the k is the number for year orders, and then here we'll just leave it as 1. So .k is equal to 1. So now if we run the data, yeah, we actually have quite a bit of variables in here. So we have all the rolling averages for the lags, and then we have here these Fourier series. So we added, a Fourier series for the date, and then also included different periods. So that's why we have 56 and 84 in here as well. And I think this should be everything for now for the data augmentation. Let's see. So the only thing that's left is we can actually delete the ID, because that was only useful for the NBeats model. So let's call this XGBoost underscore df. I always get confused with this keyboard. So in the next step, what we're going to do is we're going to define training and testing data again. So the training data is definitely going to be all the data that has non-missing rows. So what we can do is we can grab the XGBoost data frame, and then we'll use the tidyr package, and we'll say drop NA. And then we dropped all the variables where we had NA values, where we did the lags. And then we also dropped the NA values for the future frame. And actually, I'll call this XGBoost df as well. And now from there, we're defining the training and the testing data. So we have to grab the XGBoost data, and then it's the time tk function. And in here, we're going to split the data into training and testing. So the date var variable is going to be date, the date, and then we'll assess 7 days worth of data for testing. So assess is equal to 7. And I will say cumulative is equal to true. And what we get, we get the analysis, which is training, how many rows, then the testing data with 7 rows, and then the total. So what we'll say here, we'll call this split. So that's how we split the data. And then also let's make a testing XGBoost testing. XGBoost testing data frame for later. And this one should contain, well, we'll have the df data, and let's check it out again. No, it should actually be, let's actually run this again, and then I'm going to put the XGBoost testing before this one. So if we look at the last 6 rows of the XGBoost, then we have here all the variables that we've featured engineered. Here we have the lag, and then what I want to do is just going to say dplyr filter, and then we're going to say we're filtering out the dates where it's greater than or equal to the 2nd of December. This is XGBoost testing. This is going to be the split. So it's going to be testing and also then future prediction. Yeah, I should call this actually something else to make it clear. So I'll say XGBoost future. And here we have the splits. So now what I'm going to do is I'm going to use a 5-fold cross-validation, and I'll use the Tidymodels package. So what I'm going to do is I'm going to say from the rsamples package, or rsample package, I use vfold. So in our case, it's going to be 5-fold cross-validation. The data frame is going to be rsample, and then we'll say training split. So splits is going to be here again, analysis, assess, and total, and we just want to grab the analysis section. So rsample does that for us with the training function. So what we get back is the 1,385 rows from the splits here. So then v is equal to 5, and then we'll just call this XGBoost CV_5. Then we'll run this. Before that, we're going to specify the recipe. So we'll have a base recipe. Here we'll say recipe. We'll use the recipe function. Again, we'll have page views. We'll regress that on everything. And then data is equal to rsample. Then we'll use the training function on the splits object. And this is going to be the base recipe. Then what we're going to do is we're going to feature engineer some other variables. So right now we only have the lags for the page views, and we have some cosine and sine curves with the Fourier series, and then we also have some rolling averages. But what we also want to do is we want to extract some features from the date, like the year, the month, what weekday it is, maybe some quarters as well. And in order to do that, we're going to use the base recipe. And what we need to do first is, well, in this case, we've already removed all the missing values in the data set. But maybe we won't do that in the future, or we might change the data preparation step. So just to make sure, I'll use recipe, and then I'll use the NA omit step. And then here we're going to remove all the variables that contain a lag. So we did that here as well. Here we use the tidyr function drop NA where it removed all the NAs. Here we are specifically removing the lags. And then we'll say skip is equal to true. Then afterwards we'll use the time tk function. And there is a step time series signature function, and this one extracts all the features from the date. So if we'll say time series signature and run this, let's just save this as a temporary variable. So now in order to get the data set, we'll say temp, then we'll prep it, and then we'll choose the data set. So this gives us all the variables that are in the data set. So because there are too many, let's just do this, use the structure function, and this gives us all the variables that are currently in the data set. So we have 39 variables, and some of the features that we got from the time series signature function we don't actually need in our data set. So for example, we'll leave the date index in here, so it's just a numeric index. Here we have the year. We can leave the year in there. But this one, this ISO variable, we're going to delete. So we'll put all the ones we want to delete in a vector. Date half, we can delete as well. The quarter we leave as is. Then the date month we're going to delete as well. We're just going to leave the ordinal, the factor variable for the month later. This one we can delete too. Here the date month label, this is the factor variable, we're going to leave it as is, and then later on we're going to one hot encode it. The date day, we'll leave it, but for example the hour is useless because it's a daily data set or time series. Date minute as well. Then we have date second. Then we have date hour 12 we don't need. We also don't need date am dot pm. So date weekday, well, this is numeric. We're just gonna put the factor in here and one hot encode it later. So date w day we don't need. Then the xts date weekday we don't need either. Then we have date q day, we don't need that. And then this one we don't need either. We have m week. Yeah, we'll just leave this in there, I think. Date underscore week, I'll just delete. Then ISO, I'm going to delete as well. So it's not necessarily a problem that we have a lot of variables. We could leave most of them in because the decision tree already does variable selection for us. So it's not that much of a big deal like with if you do linear regression. and you have collinearity in your model, then you actually want, you don't want to have that. But also, we also want to feed the model only the most necessary variables, so it doesn't do any predictions on useless variables and wastes time that way. And also it might be confusing in certain circumstances. So that's why we want to remove as many variables as possible. Yeah, I think all of these ones, we don't need them either. And then this one we'll remove as well. So we'll call this remove variables. And then what we're going to do is, here in the recipes tab, from the recipes function, recipes package, step underscore, no, it's not step underscore remove, it's step rm, step underscore rm. So we'll first remove the date variable, because we've already extracted all the features. We don't need the date anymore. Then what we'll do is we'll use step rm, and then we'll use the bang bang rlang syntax again, and then we'll remove all these variables. All these variables in here. So what we also need to do is we're going to normalize the data set, the variables. So we'll say step underscore normalize, and we're going to normalize all the variables except for the outcome variable. So all the numeric variables minus all outcomes, they're going to be centered and scaled, and then recipes, and then we're going to one-hot encode the ordinal variables, so the weekday and then also the month variable. We'll say recipes all nominal, and then we'll say there's a function argument in there, one-hot is equal to true. So this gives us quite a lot of variables as well. So for date month, it gives us 11 extra variables, and then for the weekday, 6 extra variables in the data set as well. So if we run this, it says can't convert a character vector to a symbol. So I guess that's the problem in here. So if I run this again, yeah, I'll get, okay, so I had to do sims and then the 3 banks, because it's a vector of variables, not just one variable. So now the data set looks like this. We have 36 variables in total, and yeah, almost 1,400 rows. So what I'll do next is I'll say XGDF, and then this is the data set that we're going to use for training. And then what I'm also going to do is I'm going to say XG columns. So I'm going to count the predictors, and what we can do is if we say length XGDF, we get all the predictors from the data frame. And then what I'll do is I'll say -1 because there's also the y variable, the response variable in there. So all the variables -1 gives us the length of gives us all the columns that are going to be used in the prediction in the model, so 35 columns. And we need this later to tell the XGBoost model the range of the columns that it's going to take. So next what we have to do, we have to define the model specification, and I'm just going to call this model spec XG, and in here it's parsnip, and then in here we're going to use the boost_tree function. And if we say $boost tree, here we can see all the parameters that are going to be used for the model, and then we can train. So the mode is going to be regression. The engine we're going to set later, and then mtry is going to be tuned. Then, so mtry is, I think, the columns that's going to take. Then the trees is going to be the tree number. It's also going to be tuned. Then we'll have min_n, which is also going to be tuned. Then we have the tree depth. The learning rate, which is probably going to be the most important parameter that we have to tune. Then we have the loss reduction as well. That we're going to tune, and then what we'll do is we'll set the engine now. So we'll say parsnip, set the engine, and the engine is going to be the XGBoost engine. So now we have to specify the recipe and also the model specification here. So now what we can do a similar thing that we did here, where we have the workflow fit. So this time I'm going to call it workflow fit_xg. And then what we'll have is, it's not going to be temp, it's going to be recipe_xg. So we'll use this recipe in here. We add the model specification in here, and then we'll leave it as is, because now we have to first specify a grid of values where we tune the model on, where it can select the parameters from. And we're going to use the grid Latin hypercube to do that. So we'll say grid underscore Latin underscore hypercube, and this is from the dials package. So we'll say dials grid Latin hypercube, and then what we want to do in here is we want to tune all of these parameters in here. So we have to remove all of these ones here. And then these are actually all functions from the dials package. So we need the round brackets for each of them as well. And for the mtry one, I'm going to specify the range. So the range is going to be from 1 until XG columns, so 35. And if I run this, it says grid Latin hypercube okay, we get 3. That's probably the default. We want to get back 20 rows. So now we have 20 different values the model is going to be trained on with the 5-fold cross validation. So yeah, we'll just call this grid. And then we'll run it. And now we have to tune the model. For tuning the model, we'll use the workflow fit XG object that we've defined here. And then what we'll do is we'll look at the documentation. So we'll say question mark tune underscore grid. And here we have the object, which is going to be the workflow object. Then inside tune grid, so we'll say tune underscore grid. And here the R samples are going to be the cross validation folds in here. Then what we also have is the metrics, and the metrics we can use the Modeltime package. Let's see how the function is called. It's called default forecast accuracy metric set. So if we just run this, what we get back is mean absolute error, mean absolute percentage error, mean absolute squared error, and so on. So we're going to use this one. And then the grid, we need to specify this one as well. And this is the grid Latin hypercube that we define up here. So we call this grid. And we're not running the models in parallel. So we just let it run in sequence. And there's also a control argument, and in here we'll say tune control grid, and then we're going to say verbose is equal to true, so we can see at what fold we're at and how many models we have trained so far. And then I'll say save underscore pred is equal to true. And then what I'll do is I'll save this as XGBoost 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 k-fold. And now it says workflow fit XG is not found. So I'm not sure if I ran this one. And then I'll run this again. And then we can run this one. It gives us an error. It says arguments our samples is missing with no default. So if I run this, we have the XGBoost cross-validation sets in here. Okay, so what was missing was its resamples, not our samples. So if we run this, yeah, it's actually kind of shitty on that black background. But we see that we're on fold 1 and we've trained 5 out of 20 models so far. So we'll be back when the model is done training. Now it's finally done training. So what we'll do next is we're just going to look at the metric set that we have in here and which models perform best based on what parameters the model used. So I'm just going to say plot, and then there's the autoplot function from the workflow sets package, and then here we're going to put the XGBoost underscore k-fold object in there. And then what I'll do next, I'll say plotly, and then ggplotly plot. So now I'm going to run this, and I'm going to run plotly as well. And then in here, what we're going to see is the different parameters that we've tuned. And then here, mean absolute error, RMSE, R squared, squared mean absolute percentage error. And what's noticeable from this plot is that the mean absolute error here is around 30 when the learning rate is below minus 2.3. So if it's larger, or if it's lower than 2.3, minus 468, the mean absolute error is quite high. So what we can do is we can run the model again, just now with a different range of values. So what we can do is we can copy this, paste it below, and now we can also specify the range for the learning rate. So we can say range is equal, so let's say minus 2.4, and then where was it here? To minus 1. So now we're going to run the gridlet and hypercube again, and now the range is only going to be from minus 2.4 to minus 1. And then we're just going to override the object we had previously with the different range for the learning rate, and we'll run the model again. Now this model has been trained as well. Now what we're going to do is we're going to extract the best model from there. So we already defined the workflow in here. So we'll need that object again. Then from tune, we'll say finalize workflow. And then afterwards, what we have to do is we have to get the trained object. And then from here, what we can do is from the tune package, we'll say show best, and this gives us a warning message that no metric was selected, so it defaults to mean absolute error. And we see it's around 30. So on average, it's around 30 page views off, plus or minus. So what we can then do is we'll use dplyr to get the first row. This gives us then the best model with the best parameters. So it used 17 columns, 1,300 trees, learning rate, loss reduction. And then what we'll do is, so now we're going to train on the entire training data. So here we split the training data into 4 folds. There was supposed to be the training data plus the 1 fold was then on testing. So I think it's an 80-20 split. So now to test on the entire training data, we'll use parsnip again. And then what we'll do is we'll fit it on the training data. And then what we'll do is we'll say final XGModel. So now we can run that. And after this is run, what we can do is again, we can go to the NBeats model and we can copy all of this. Then we can go down here, and now here this is the workflow fit for the NBeats model. And we also have a workflow fit for the trained XGBoost model, which is final XGModel. And what we'll do, we'll just run this. So now our models look like this. We have an NBeats ensemble model, and we have a XGBoost model. And then again, we'll call this all models prediction. We can use the Modeltime forecast function again. These are the models, and let's run that. So this gives us an error. So I think this is because of the actual data. So what we'll do is we'll look at testing. Testing also looks like this. So what we need to do is we need to grab the testing data where we have the lagged variables. And this one was XGBoost future, I think. It started on the 2nd. So we'll use this for the new data. The only thing we need to do is we need to add the ID. So ID is equal to as.factor1 for the NBeats model. And then for the actual data, what we can do is we'll grab here this XGBoost underscore df function, and if we're going to look at the last 6 rows, it goes until the 8th, which is good. I'm not sure if I have to do if I have to add the ID variable in here as well. I'm just going to do it. And then what we can do, we can filter it again. So we'll say filter date is greater. We'll use the looper date package and the year, month, date function for the 11th so greater than November 1st. And hopefully this works. So the models have been trained, or the predictions have been made. And then we're going to plot it. So these are the actual values. So we can see that for the first week, so the XGBoost model also wasn't trained on dates past the 1st of December. And we can see that for the first week, it's definitely doing better than the NBeats model. And it also goes down, especially here for Christmas, the 24th, where we see a low. I think it's, it might also be better for the 21 days for the predictions here, but we'll have to see. It's definitely doing better for the first week where we have the data available. So we're not going to deploy a model for the Shiny application. What we want to do is we also only want to use the forecast plot in the actual application. So if we look at all models underscore preds, that's a rectangular data frame. So what we're going to do is we're going to use the readr function, then we're going to write CSV. Going to use the here package, then we have to go into the GA dashboard folder, then into the data folder, and then we'll just call it time underscore series dot CSV. If we go into files and then run that, we have the time series CSV data in here. So what we're going to do next is, in here we'll say time underscore series, and then we're reading in the data set that we've just created. And then what we also need to do in here, we have to add another ID. So let's just go with H. That's the ID for the time series forecasts. Then we have to set a data frame. So we have Google Analytics for the Google Analytics data, Search Console for the Search Console data. And in here, we'll just say time underscore series. And we'll do that here as well. We'll say time underscore series. Here we have to add the ID, and then we have to add the header that we're seeing in the app as well. So we'll say time series, and then here we're going to say time series as well. So what we have to do now is we have to go into the main visualization module, and then we're getting the data from the database, and I already included the time series header and the IDs in the Mongo database, so it's already in there. So if we're reading from the database, this one already, the code here already figures out what data frame we need and what IDs we need and what header it's going to be. The only thing is that we have to do in here, currently there are only two data sets, the Google Analytics data and the Search Console data, depending on what the header is and what data frame we need. So in here, what I'm going to do is I'm going to say else if, and else if C is equal to SC. So here we specified SC and GA. So if it's equal to SC, then it's going to be the Search Console data we're going to use. inside the Google Analytics function, which produces all the visualizations, and else it's going to be time series, the time series data frame. So what I have to do is I have to add this here as a function argument, and then I have to add that here in the app.r file. So times, or let's do it actually where we're inputting the other data as well. So these data frames come from the filtered dates module. So these data frames are reactive. However, the time series data frame is not reactive. It's going to be static, and we just have to update it maybe every week with the new data, and we have to train it again. We can write a script for that to just automate it or do it manually. It depends what you want to do. So here in the main visualization module, we defined this here. We call it time series. And in here we don't need the round brackets because again, this is not reactive. Whereas Search Console data and GA data, depending on what dates are selected, they are reactive. So here again, we'll say else if. So else if dot y is equal to sc, it's going to be sc, else it's going to be time series data. And then here again, and otherwise we're going to use the time series data. So that looks good. The only thing that we need to do is we have to go here into the Google Analytics function that we've created. In here, and I already put it in here. So we have time series. So we called it in this vector. We called it time series. So the name in the Google Analytics function has to be time series as well. And then we'll just use the plot model time forecast function. And then the data frame, it's going to be selected based on what it is in here. So we'll save this. This looks good as well. So let's see if it actually works. So here we have the session duration, the page views, and the visitor map. And now in here we have an action link with the called time series. So we're first going to delete the session duration, the visitor map. Then we're going to click on time series, and we get back the time series forecast. And then if we delete it, it should pop here into the sidebar. So that was everything for this video. In the next video, what we're maybe going to do is we're going to connect to the APIs, and then we're going to deploy the entire app with Docker on either AWS or maybe Heroku. We'll see. I'll see you next time.